Greetings once again. My name is John Gabriel, and in this video, I'm going to answer a question from this user who's asking me to show how to use the identity to find definite integrals and the derivative. So that's what I'm going to do, and I'm going to use an example that I've already used here on Discord. So if you join Discord, you'll be able to follow the steps of the very example I'm going to illustrate to you now, okay? So the derivative is easy. The derivative is just simply this length of f2 divided by h, and we get 7.75, right? So because the derivative is, let's write out the derivative will be 4x minus 1 over x squared, right? And we get that from this formula here, right? So if we take the derivative at 2, it will be 4 times 2, which is 8, minus a quarter, which is 7.75 as expected, okay? So it doesn't matter where you position how you position h or whatever you do, it'll always be the case, okay? So if it's 4, then it'll still be 7.75. It doesn't matter what the value of h is because f2 changes accordingly, right? So now this is how you find the tangent line. So that's a derivative. Now, in the integration, you would be looking at the integration of the derivative function. In other words, the area under the curve of the derivative. So here we see the primitive function, which is that one. And here we see the derivative, which is this light blue one. Okay, so this light blue function here is the derivative. And when we click OK, and we see that the area from x equals 2 to x equals 8 is 119.625, and that's easy to find. It's this 46.5, which you see over here. Let me just put that to 8 again. I'm sorry. Put that to 8, 6. Yeah, so it's 46.5. And the difference in slopes is 73.125, isn't it? And it's this value here, 73.125. So we add those, and that gives us the area under the curve, which is what we need. Okay, so that's the same as taking the secant lines, the non-parallel secant line slope, and multiplying it by 7.75. All right, and subtracting h times 7.75. So you can follow these steps, and if you have any difficulty, you can come over here and see how they're done exactly. And of course, it doesn't matter what the value of n is, because this value here will always remain the same, okay? Excepting the difference will become less and the green area will increase, okay? So if you had to do that, well, then they're almost the same, right? So coming back to you've got access to these applets, and I'll put a link into them, where you can actually type in these functions like this. And remember, you'll have to resize the axis to be able to see it, okay? So that's pretty much it. I hope I've answered your question. That's how you can do it. And this part here on 9.48 here, so let's just have a look at this. So what I've said here is that, no, it's still running. I don't know why. Hang on a second. I want to stop it and just go to, yeah, I wanted to go here. So for example, if you have, if the top or the numerator of a fraction like this is 0, it doesn't matter if it has x's in the denominator. You know that you have found the derivative, okay? You know that you have found the derivative. So a good example of that is, again, the same one that I gave you here on Discord. And you can also go to, I'll put a link to an article in academia where you see plenty of examples using the new calculus derivative. And you'll know how to do that as well. So once again, become a subscriber if you're not already. Tell your friends about this. Follow me on academia. And if you've got some spare dollars, donate at the link in the details section. Till next time, I'm John Gabriel. Goodbye.